Cones. A cone is like a pyramid whose base is a circle. The most common cone is a right cone. In a cone, there are three dimensions of interest. The first one is the lateral area, which is the on the side of the cone. We call that L. L for lateral area. The height of the cone is what we've been using the letter H for the height. And the third dimension that we need is R, not the third dimension, but the third thing that we need is R, radius. There's also such thing as an oblique cone, and we'll talk about that in class. But we're going to focus on lateral area of right cones. So to find the lateral area, that would be like unwrapping that cone. So the lateral area is the side. So I'm just going to have us think about the sides like this. If we were to unwrap that, what would it look like? It would look like something like this, where L would be the sides here. L are the two sides of this opened up cone. And so I'm going to make this look like this. So that is the whole opened up cone. What would this be a part of? If I make a dotted line here, you can think about the unwrapped lateral area of a cone as being the sector of a circle that has a radius of L. So if we can find the area of this sector, we can find the lateral area of the cone. So what is the area of the entire circle? Well, I will erase this, and instead of L, I'm going to call this 6. What is the area of the entire circle? The area of the entire circle is 36 pi, pi r squared. We want just this proportion of the circle, and so it would be to do with the circumference and this little arc. So what is this little arc? This little arc here, maybe I'll do it in this kind of color here. Yeah, it's not too much different. I'll do it in pink. This, whoa, way too big. Undo. This part here we can think about as being, would be just the circumference of this cone's base. So the circumference is 2 pi r, and for this problem it would be, what's the r? R is 2, so it's 4 pi. Okay, so now we want to figure out what proportion this is of the entire circumference of a circle that has a radius of 6. So what I would do is I would multiply this times 4 pi, which is the arc length here, divided by the entire circumference of a circle of radius 6, which is 2 pi r, which is 12 pi. So this is the arc length, and this is the entire circle. So if you do math out here, the pi's will cancel. This will be a 1. This will be a 3. 36 pi divided by 3 is 12 pi. So that would be the area, the lateral area of the right cone below. So again, we're trying to generalize to get to a formula, which we will do on the next page. In general, if we unwrap this cone, it would be this area of this sector is the lateral area. In general, this is called L, which is the radius of this imagined circle. L is the lateral length. And this distance from here to here, is 2 pi r, which is the area of this cone's base. Not the area, the circumference of the cone's base. So the lateral area is the area of the whole circle, which is pi L squared, that's this whole dotted line circle, times the piece of the arc, which is 2 pi r, divided by the circumference of this whole circle of radius L, which is 2 pi L. Simplifying, a lot of things are going to cancel here. The 2 pi will cancel with a 2 pi. One of the L's in the denominator will cancel one of the L's in the numerator. So it's simplified as pi r L. So the lateral area of a cone is simply pi r L. The surface area, as always, is the lateral area plus the area of the base. For a cone, the lateral area is pi r L, and we would add it to the area of a base of a circle with radius r, which is pi r squared. So surface area is this formula, and the volume is the same idea as a pyramid is to a prism, as a cone is to a cylinder. It's 1/3 the area of the base. What's the area of the base of a cone? Pi r squared times the height. So let's do a couple of examples. A right cone has a height of 6 and a radius of 3. Find its slant height. The slant height is going to be this Pythagorean situation. So it would be 6 squared plus 3 squared, which is 36 plus 9, which is 45. So the slant height is the square root of 45, which is 3 root 5. The lateral area is defined as pi RL, so that would be pi times r for this problem is 3, and the slant height for this problem is 3 root 5. So combining 3 root 5. 3 times 3 is 9, so it would be 9 pi root 5 is the lateral area. The total area is the lateral area, which is 9 pi root 5, plus the area of the base. Well, if it's a circle with radius of 3, the area is 9 pi. Now, you cannot combine 9 pi root 5 plus 9 pi. This one would have to have a square root 5 next to it, so this is totally done. The volume is 1/3 times pi r squared. What's pi r squared for our problem? R is 3, so it would be times 9 pi, which is the area of the base, times the height of 6. Simplifying this, 54 divided by 3 is 18, so the answer is 18 pi. So notice for a lot of these cone problems, you sometimes have to use Pythagorean theorem to figure out the things that you need. Example number 2. A right cone has slant height of 6 and a total area of 40 pi. So the slant height is 6 and the total area is 40 pi. Find its volume. So to find its volume, we're going to need to find the radius. So that's the missing piece here. So how we're going to do this is we're going to look at the formula which says the total area, which is 40 pi, is equal to pi RL, which is the lateral area, plus pi r squared. So we're going to put in the numbers that we're only given 6. So it would be 6 pi r. Oops, I forgot the 40 pi. Here. 6 pi RL plus pi r squared. Notice that the pi's are going to cancel, and we're left with 40 equals 6r plus r squared. This is a quadratic, so we can see if we can solve this. So I'll do this much and see if you can finish the problem. Find r and then find the volume, which is what the problem was asking. Question number 3 is a doozy. It's a good one, though. So I'm going to see if you can draw it, if you can think about what it looks like, and here's a hint. Question number 3 is a really good one. So do that at home, and we'll talk about these things on Monday, or next class, actually.